All right, so we're looking at number 9, the arctangent of the square root of 3. Now, arctangent has a specific range. Does anybody remember what range we gave tangent? Or arctangent?
Left side of the right side.
Yeah.
Does anybody remember the values? What were the values?
Pi over 2 to pi over 2.
So negative pi over 2
I don't know if it's right.
to pi over 2. This is actually correct. But do we use parentheses or do we use brackets?
Parentheses.
Why do we use parentheses? What does tangent have that sine does not have?
Asymptote.
Right, so we're using parentheses because of the asymptotes. Okay, so we have asymptotes and tangent, which means that basically we cannot include negative pi over 2 and we cannot include positive pi over 2. But everything in between is fair game. So I'm going to highlight just outside of that little dot. And here we have the range of arctangent. So if we're looking for the range of arctangent, and we're looking where this is going to be equal to the square root of 3, what can we eliminate right off the bat of all of these values here?
The negatives.
Yeah, the negatives, because any of these will give me a negative number, so I obviously can't have that. Now, if tangent is y divided by x, that would be 0 over 1. What would this give me?
0.
So it obviously can't be that one. What about this one? What if I divided square root of 2 over 2 divided by square root of 2 over 2? It's going to give me 1, right? So it obviously can't be that one. So I'm basically left two choices. I'm left either square root of 3 or square root of 6. Which one of these is going to be my answer? How do y'all know that? All right, let's try it. So what we're going to do is we're going to do the square root of 3 over 2 divided by 1/2. How do I divide a fraction by a fraction? We multiply by its denominator's reciprocal, which is 2 over 1. What happens to the 2's? Nice. They cancel out, and my answer is the square root of 3. Right? So that's the answer that we're looking for. We found it where? So your answer to this would be the arctangent of the square root of 3 is pi over 3. All right, let's go ahead and move on to today's lesson. So we're at 4.7, day 2. Now, our warm-up activity is to graph at least one period of all 6 trigonometric functions that we've learned so far: sine, cosine, tangent, cosecant, secant, and cotangent. Yes, all you need to do is graph them. Just the parent functions. You should be able to do this by hand, by memory. You should not need a calculator. You should not need a unit circle. You should know what these look like by now. All right, so we're going to go ahead and review how to do these. So everybody should be able to graph these at this point, but just in case you are having trouble, we're going to very, very quickly review how to graph sine, cosine, tangent, secant, secant, and cotangent. So let's start off with sine and cosine, the first ones that we learned how to graph. Now, if you guys remember, sine and cosine look pretty much the same, except for what? Which one is the one that crosses the origin? Sine crosses the origin, and then it follows a pattern that we become used to, right? It crosses through the 0, then it goes, bless you. So take 2. It crosses through the 0. Not kidding. No, but yeah, so sine crosses through the origin. It crosses through the 0, then it goes all the way up to 1. It crosses through the 0 again, then -1, 0, 1, 0, -1, and it just forms a wave that continues on forever. So here we have the graph of sine. The graph of cosine looks very similar, except that it begins where? Right, it begins above the origin, so it begins at the top of the hill. Then it goes to 0, then it goes to -1, then 0, 1, 0, -1, then 0, and again, it creates an infinite wave that goes on forever. So this is the graph of cosine. Now, tangent's a little bit different. Tangent, does tangent cross through the origin? Tangent does cross through the origin. right? Cotangent is the one that does not cross through the origin. So tangent, the difference between tangent and cotangent is basically where they begin. So tangent crosses through the origin. Oh, and also their orientation. Tangent has a positive orientation, which means it looks like this. It begins with the left pointing down and then the right ends going up. And cotangent is the opposite. It looks a little bit like this. So what happens at pi over 2 in the graph of tangent? It actually has an asymptote. At pi over 4, which is right here, pi over 4, tangent is actually at 1. So the graph of tangent actually looks a little bit something like this, with asymptotes at every single multiple of pi over 2. There's more asymptotes here, more asymptotes here. And of course, it crosses through the middle at pi. Any questions about tangent? All right, cotangent is very similar to tangent. It has asymptotes at x is equal to 0. It crosses the x-axis at pi is equal to 2, but the orientation will also be different. So the orientation will begin on the left side pointing upwards, and then on the right side it will end going downwards. So it should look something like this. And this would be the graph of cotangent. Now, when it comes to secant and cosecant, the easiest way to graph secant and cosecant is to graph sine and cosine and then go from there. Knowing that anytime that sine and cosine cross the x-axis, you're going to have an asymptote, and at the top of the hill and at the bottom of the valley, you will have parabolas pointing away from the center of your graph. So what I mean by that is this. I'm going to go ahead and take to graph cosecant, I'm going to go ahead and graph sine. So everything is the same that I did with sine. Also realize that this box has a value of 2, so every single square on this grid has a value of 2, so I'm only going up halfway to denote the value of 1. So here I have the graph of sine, and here I will have the graph of cosine. And if you compare these two, you should see that they look very, very similar. Now, what am I going to do anytime that sine crosses the x-axis? We're going to have an asymptote. What about at the top of the hills and at the bottom of the valleys? We are going to be adding parabolas. And we're going to follow the exact same pattern with cosine and secant. Parabolas at the top of the hills, at the bottom of the valleys, and asymptotes wherever they cross the x-axis. All right, so moving on. Composition of trigonometric functions. It basically says that if you have an inverse function and a regular function, or the original function, that if you compose them, which means something like f of the inverse of f of x, then it's going to give you the identity function, or x. So what's the answer to this? Yeah, the answer is just x. Why? Yeah, an original function and its inverse will cancel each other out. What about this one? What's the answer? It's x as well. Why? Because the inverse function and the original function will cancel each other out. Another way to explain it is with an actual function. Let's say we have y is equal to x minus 2, and we have its inverse y, or inverse of y is equal to x plus 2. If I have a number like x is equal to 6, and I do x, or 6 plus 2 minus 2, what will my answer be? 6, right? That plus 2 and that minus 2 are basically canceling each other out. So we're going to apply this same logic of inverses canceling each other out to trigonometric equations. So tell me, what would be the answer to that first problem? The sine of the arcsine of x. It would be just x. Why? Because the sine and the arcsine cancel each other out. Catherine, what is the arcsine of cosine of A? Yeah. Why? They cancel each other out. All right. Anybody? Tangent of the inverse tangent of 0.78. What would be the answer? 0.78. Why? Nice. Bless you. Okay, so this one says list the restricted domains and ranges for each of the following trigonometric functions. See if you can do it without looking anything up. This goes to what we were talking about last class. We restricted the domain of sine, we restricted the domain of cosine, just so that we can have the inverse be functions instead of just graphs. So does anybody remember what we restricted the domain of sine to? So we have negative pi over 2 to positive pi over 2. Did this come with parentheses or brackets? Brackets. What about its range? Close. The range of tangent was negative infinity to infinity. Negative 1 to positive 1. That's exactly right. If we look back here to the graph of sine that we did, the highest it ever went was positive 1, and the lowest it ever went was negative 1. So from 1 to negative 1. That would be its range. Okay, cosine. Somebody give me the domain for cosine. No, for cosine it changed. It's different than sine. It would be from 0 to pi. What would be its range? Negative 1 to 1. This would be the same as sine. Now finally, tangent. What is the domain of tangent? We already have its range, but what is its domain? What do you mean? It's not the same as the range. Nathan, what did you say it was? Negative pi over 2, comma pi over 2. So the exact same thing as sine? Yes or no? No, because this one has parentheses. Exactly. If you guys take a look at what we did over here with our unit circle when we were reviewing, you will notice that here we talked about the domain of tangent having parentheses. Do you guys remember that? Yes. All right, cool. So the inverse tangent of the sine of pi over 2. Okay. I'm going to go ahead and do this off to the side. You guys feel free to watch. You don't have to copy anything down just yet. You can do that later. But we're going to do the inverse tangent of the sine of pi over 2. Okay, how would you go about working something like this out? Yeah, so actually what you're going to want to do first is, just like Ashley said, you're going to want to find the sine of pi over 2. Now, your first instinct might be to go towards your unit circle, but I want you to refrain from that for a second. All right? You guys are at the point where you should be able to draw your own unit circle or not need it at all in the first place. So here I have just a plain circle, and I'm going to show you just what I need to answer this question. So for example, I'm looking for the sine of pi over 2. Now, if I'm talking about pi over 2, so I can say, okay, this is going to be 90 degrees. This is going to be pi over 2. And so what is going to be my coordinate point right here? 0, 1. Does that make sense? All right, so if it's 0, 1, what is my sine of pi over 2? So really what I'm looking for is, I'm not looking for the inverse tangent of sine of pi over 2. Well, I am, but to put it a little bit more simply, I'm looking for the inverse tangent of 1. So in other words, where on my unit circle that falls within the inverse tangent's range is tangents equal to 1. So once again, their range is going to be from here all the way to here. So on this side of the unit circle, where would the inverse tangent give you, or where is the inverse tangent of 1? Where would tangents give you 1? Pi over 4. Why do you say pi over 4? So it's just pi over 4, or 45 degrees, and you said that this is equal to the square root of 2 over 2 and the square root of 2 over 2. If I were to divide these two, what would I get? This would give me 1. And so that's exactly right. My answer is going to be pi over 4. So for question number 2. Now this is a case where it might not be as simple as it seems at first. Based on what we covered right up here, what do you think you should do with the arcsine and the sine? That would be your first instinct, but you can't do that right away. Let me tell you why. Let's actually pull up a unit circle so we can explain this a bit better. We're looking for the arcsine of the sine of, what was it? 5 pi over 3. So your immediate reaction to something like this would be, oh, let's just cancel these out. And the reason you can't do this is because, can we take the arcsine of 5 pi over 3? Can arcsine give you 5 pi over 3? The answer to that is no. This basically can't happen. And the reason it can't happen is this. If we were to highlight everywhere where arcsine is allowed to exist, which is quadrant 1 and quadrant 2, and we looked at 5 pi over 3, well, that begins from here, going all the way this way to 5 pi over 3, are basically saying 300 degrees. What is the range for arcsine? It should be negative pi over 2 and positive pi over 2. The range for sine is negative 1 to 1, but the range for arcsine is negative pi over 2 to positive pi over 2. And so we need to stay between these two numbers. You could also say that this is from negative 90 degrees to positive 90 degrees, right? And looking at it this way, 300 degrees definitely does not stay within those bounds. Does that make sense? So how can I get to this point without going 300 degrees? You have to go the other way, the negative way. What would be the value of this reference angle that I have here? Negative 60 degrees or negative pi over 3. Are both of these values within this range? Yeah, so that would actually be your answer, negative pi over 3. Because the fact of the matter is you're looking for the sine of 5 pi over 3. So sine of 5 pi over 3 is negative square root of 3 over 2. So you're looking anywhere here within its range that gives you negative square root of 3 over 2. And the only thing that does is this value, but going in the negative direction, which is why we have to use negative pi over 3 instead of 5 pi over 3. Questions about this? All right, so here we have negative pi over 3. That's our answer. Number 3, I'm going to let y'all do on your own. 4 and 5 on your own. I want you guys to look at number 1. It says consider the quadrant and draw a triangle. Find the missing side and solve. So for this one, it's going to be a little bit different. I'm going to go ahead and draw it out. You guys feel free to copy at a later time if you want to. I will leave these notes up here. So let me just go ahead and do this off to the side. Now, what is the question that they're asking me? Can anybody tell me? We're looking for the tangent of the arccosine of 2 over 3. Now, this one, you're going to require the use of an old friend. So katoa. Now, what this basically says is that the sine of theta is equal to the opposite over hypotenuse, that the cosine of theta is equal to the adjacent over the hypotenuse, and that the tangent of theta is equal to the opposite over the adjacent. Now check out what we're going to do. What I'm going to do is, first and foremost, I'm going to go ahead and get rid of that arc cosine. I want to get back to regular cosine, and the way I'm going to do that is by taking the cosine of both sides. So I'm going to work with just what's inside the parentheses first. So the arc cosine of 2 over 3 is equal to theta. It's equal to some angle. We don't know what angle that is yet. Can you tell me, though, what quadrant that angle has to be in? Quadrants what? How do you know it's quadrants 1 and 2? Well, why? this angle has to be between quadrant 1 or 2 because it is an arc-cosine function. So if it's arc-cosine, it has to stay between 0 and pi. So it has to stay in one of these two quadrants, either quadrant 1 or quadrant 2. Does that make sense? Because it has to be between 0 and pi. So what I'm going to do is I'm going to take the cosine of both sides. Cosine of this, cosine of that. The cosine and the arc cosine are going to cancel out. And what I'm left with is the cosine of theta is equal to 2 over 3. Now, what does cosine tell me here? What is cosine equal to? Brandon, what's cosine equal to? What's cosine equal to? Yeah, but what's it equal to right here? Right here. A over H, which stands for adjacent over hypotenuse. So if my adjacent side has to be, well, frankly, they both have to be positive, then my adjacent is going to be 2. So 1, 2. And then hypotenuse is going to be 3. 1, 2, 3. So what we're going to be left with is a sort of trigonometric triangle, with this being 2, this being 3, and we have a missing side that I'm going to call B. How would you find the missing side of a triangle, especially a right triangle? Pythagorean Theorem. So a squared plus b squared is equal to c squared. I go ahead and substitute the a and the c's for the values. So we have 2 squared plus b squared is equal to 3 squared. So I'm going to have 4 plus b squared is equal to 9. Subtract 4 from both sides. I get b squared is equal to 5. So b is equal to the square root of 5. So we have, what we're actually looking for is the tangent of this whole thing, right? Well, what is tangent equal to? Opposite over adjacent. So if this is my angle theta, my opposite is right there, my adjacent is right there. What should be my answer? Square root of 5 over 2. Yeah, this is going to be my answer. Square root of 5 over 2. All I'm doing is I'm building the triangle and then putting in my answer.